All right. So here, let's take a look at your hands-on. You have two questions. They're both about normal forms. The first question is kind of like what we did last Monday, I believe. So basically, you have violation of first normal form. So why is that? If you look at every cell, okay, every cell, the transaction column has, this cell has two values, right? And also this one has two values. Make sense? So basically, we have three columns which are multi-valued attributes, right? So we have to handle that. But this one, address is not. Address is 101 Sarah Lane and 106 Sunset. So this is just one value. Does it make sense? Okay, so this one is fine. The address is fine. But just transaction number, transaction type, and the transaction amount, all of them are multi-valued attributes. So we are going to handle that as a weak entity. So this is what I'm going to do. Let me go to whiteboard. Let's create a new one. All right, so so you're going to take all this attribute, all those multi-valued attributes out to create like a weak entity thing. So in here we have transaction number, which is going to be part of primary key, even though let me make this version exposed here so that you can see what I'm talking about in the same screen. So get rid of that. Okay. Put this over here. So you have transaction number, transaction type, transaction type, and then transaction amount. A-M-T. Here, that just could be anything, could be yes or no, could be optional or not optional. And then on the other hand, we have strong entity, which basically in this case, we are going to have ID. Okay, so we need to decide what will be the primary key for that part yet. Name, account number, and balance. Okay, and then account owner rule. Okay, account type, and account owner rule. So here we're going to decide, but anyway, this is going to be just like a weak entity. I'm going to create the weak entity first. So let's just call that as transaction, right? Okay. Now let's take a look at this part, the left-hand side. So left-hand side, basically, you're going to look at the table here. So ID cannot be primary key because ID is repeating, right? You see that 109, 109 here. Account number cannot be repeat, cannot be primary key either alone. So you see this primary key value 1, 2, 3, 4, 1, 2, 3, or 4 are repeating. So therefore, you really need both, right? So you really need both customer ID and account number both. Okay. So one student asked me, how do you decide? How do you decide what should be primary key? Well, just use your knowledge of cardinality here. So one customer can have many accounts, and one account can have many customers. So therefore, you really need both ID, customer ID, and account number to uniquely identify each record here. Each record consists of customer record and also account number combined. So you know that this is actually violating the second normal form. So let's just put this ID and account number both as a primary key, as like ID for this joint lib ID. And then here the name, I can just say this is required, this is required, this is required, does not matter, okay? So eventually we are going to have something like this, and then this is a strong entity, but this is a weak entity. So this is the first thing we will do. For multi-valued attributes, take it out and make it a weak entity. Okay, so we can call this, what do we call this? This may be just like a customer accounts, right? Customer basically is a whole thing. Customer accounts, but it's kind of a jointly. Okay, so based on that, and now we can fix that violation first. So we are going to create a table with all these attributes like customer ID, customer name. The customer ID is a primary key here. Account number, part of primary key. And then account balance, right? And then account type. And then account owner rule. Okay. And then whether, so basically that tells whether the owner is the first primary owner or secondary owner. And then the weak entity part is clear. So basically you're going to have transaction number. And that's part of primary key. Transaction type. And the transaction amount. All right. So we say that was there is one transaction type is required and this is optional. So we can put this down here. Required is optional. Okay. And then for this one, this is required. Balance is required. Account type is required. Is required. So basically, just based on what I put on this on the ERD. So this is the first step after finishing. Oh, not yet. So you are going to duplicate the primary key from strong side to the weak side. So in this case, what should be primary key? You're actually going to have ID and account number, both duplicated here into transaction table as a part of primary key. You're going to have ID, customer ID, and the account number together as one foreign key. And also that part, that foreign key will be part of a primary key for this table. Does it make sense? So this is the first step. So that after violating the first normal form, so we can say this table, first step one, the table is not in first normal form due to the presence of multi-valued columns. So we have 3 columns like that, right? Those are columns like account number, transaction number, transaction type, and transaction amount. Good. So specifically telling that these are multi-valued attributes. So to fix that, we are going to treat those multi-valued attributes out, take those out, and then make it like a weak entity. So we end up with these 2 tables. Okay. Now there should be no more multi-valued attributes. So if you have like a transaction number, then you have just one transaction type and then one transaction amount, and corresponding to one customer and one account, right? So each row, each cell will have single values. So and then we need to fix second normal form. So what are the second normal form possibilities? So we already know that this ID, basically customer ID determines customer name, right? And account number should determine balance and account type, right? Is that clear? And then account owner rule, that really depends on both, I believe, because you need to say which customer and which account which customer and which account. So this the owner row. So for example, one customer may be primary owner for the one account, and he or she may be secondary owner for the second account. So in this case, the account owner row depends on both. All right. So this table is not in second normal form. So we can just write that down. So how do we write that? You can see this table, just trying to, instead of typing the whole thing again, I say this. Yeah. Oh, there's the address column too. I missed that. Yeah, depends on the ID. Yeah. So it depends on ID. So that's right. So thanks for pointing out that. I think there's a mistake. So address actually depends on, address should be in here. So if we trying to add that, okay, just something here. And then let's try to make this slightly bigger. And then put address in here. Address. So let's just say that is also required. So then you're going to put address in here. Let's just put address here. So that also determined by ID. Okay. Very well. Okay. So the table is not in second normal form due to partial FDs. Okay, partial functional dependencies. And those are dependencies, those are as follows. So for example, ID, which is part of primary key. Okay, so let's just write that clearly. So primary key first. Primary key consists of ID and account number. And then we have ID determines name and address. Okay. And then account number determines balance and account type. Okay. And so that's the reason. So we let me just try to simplify that. So ID and account number all together determines account owner row. So these two are partial FD, and this one is fine. Basically, this row depends on the whole primary key. So only these two are partial FDs. Okay. So to fix that, we are going to make 3 tables. The first table is going to have ID, name, and address. Okay, so with ID as a primary key. So this might be called like a customers table, right? Customers table. And the second table is about account number, account balance, account type, and the balance. So this table is about accounts. Okay. And then finally, you have a table with both ID and account number as primary key, and that account owner rule. So this is more like gerund. It's a gerund between customers and accounts. So that first table, the first table is violating second normal form, and this is we fix it and break it up into 3 tables. And now what about the second table? So the second table, you have transaction number, transaction type, transaction amount, and each transaction number and account number and ID and account number is a primary key. So basically, in this case, you have a situation like this. You have a primary key consists of 3 columns. So second table, let me just try to write that down here. Account type. I'm trying to draw a line so that we know what we're talking about. All the way down. Okay, so now let's take a look at that table. So that table has basically is about transactions. So you have transaction number, transaction type, and the transaction amount. Okay, and then we have two extra columns. One is customer ID, another one is account number, and this all 3 must be part of a primary key for this table. Okay, so now let's see whether this table is violating second normal form. So basically, do you see any partial functional dependencies? For example, transaction type determines on transaction number only. Transaction amount determines on the transaction number only. So if you look at here, that is not true. Basically, the transaction number is local for each account, for each customer, for each account. Okay. So for example, this transaction number 1 is debit, but the 2 is credit. And then here, the transaction number 1 is credit. See that? So there's no relationship. So based on the transaction number, you cannot tell what type of transaction is it. Of course, you cannot tell the amount. The amount cannot be determined by any one of those. So this is the case that we have transaction number and the transaction account, or transaction type and amount. They all depends on all 3 columns. So the functional dependency would like this. All 3 columns determines non-key columns, transaction type, and transaction amount. So this table is fine with second normal form. So this table is already in second normal form, and there's no partial functional dependencies. All right, so after fixing second normal form, we end up with how many tables? We end up with 1, 2, 3, 4 tables. Let me try to pull this up, make this bigger so that we can see everything. Okay, so we are going. So we end up with 1 table, 2 table, 3, and 4. Let's lost this table here. Okay, and then when you decide whether this table is violating third normal form, let me check. Is asked that in the first third normal form? Yeah. So we check third normal form. So to check third normal form, we have to make sure that we kind of find non-key column depends on other non-key columns. So for the first one, first table ID, customer name and address. So we have only 2 non-key columns, name and address. They don't depend on each other, right? If you know the name, you cannot tell the address. If you know the address, you cannot tell the name. Does it make sense? So in the same address, you may have several people with the same name, right? Okay, so therefore this table is already in third normal form. No problem. And then what about the second table? Account type and the balance, do they depend on each other? So if you know the balance, can you know the type? No. If you know the type, can you know the balance? Of course not. So this table is also in third normal form. And the last table will be automatically third normal form. You know why, right? Because it has only 1 non-key columns. Okay, so we can just take a shortcut. Now, what about the first table? So first table, we have 2 non-key columns. So basically transaction type and the transaction amount. They cannot tell each other. So if you know the transaction type, you cannot tell what is transaction amount. If you know the transaction amount, you cannot tell what is transaction type. So this table, this one and this one should not depend on each other. So therefore, this is also for the normal form. So and the result, those are the 4 tables. Okay, those are the 4 tables. We basically just fix in the first and the second normal forms. We end up with the whole, everything, which also satisfies for the normal form. Any questions on this one? Yeah. So if you're trying to draw analytic relationship diagram, what does it look like? That's a good question. So this is actually showing like, so you're trying to draw like that. So you're going to have a customer table. Okay, you're going to have account table. Okay, and then you're going to have a gerund in the middle. Gerund here. So that basically just have one column, one row, which is account owner row. Let me just write here. So that's one column, tells which customer is for primary owner of certain account, or which one is secondary account, secondary owner. And then for transactions, actually it's a little bit interesting. For transactions, look like this. So you're going to have a transaction number, transaction number, and then transaction type, and then you have a transaction amount, okay, and then this is maybe like that, and then you're going to have something like this. It's more like a gerund also, something like that, which will get a primary key from customers into here and all account number into here as part of primary key. So this is kind of a gerund here. But this gerund has its own partial ID, kind of, yeah, like that. That makes sense? So this maybe just like a transaction. Transaction, okay. All right, does anybody have questions about the first one? First one. Does ask you for ERDs? Or you just draw the ERD that represent that, yeah. Draw the ERD represent that. Okay. Now let's take a look at the second one. Second one asking for Boy's card normal form. So if we're going to look at this, so we have a student ID, instructor, and a class, and review date. So you can look at the context. You're pretty much clear that we are talking about tables or records about teach student take class and instructor teach class, something like that. So based on that, so without looking at data, I can make a judgment that student can take many classes, right? And class can have many students, of course. And then one instructor teach many classes, but one class can have only one instructor. Is that right? One class and one instructor. So if I know the class, I should be able to tell which instructor. So therefore we found one functional dependency, that is class ID determines instructor. So that is how we end up with the functional dependency that we're looking for. So we found that class ID determines instructor. Okay, so now you ask, is class ID the primary key for the table? Of course not, because one class can have many students, right? So if you know the class, you cannot tell who is taking the class. Does it make sense? So even though class ID determines instructor, but the class ID cannot determine student ID. Okay, so but yet class ID is not a key. Okay, so determinant is not a key. Therefore, the table is not in Boyce card normal form. Is not in Boyce card normal form. Okay, so how do we fix that? So we're going to use the transistor class ID that determines instructor to make a new table. So the table will look like class ID as a primary key, instructor is non-key column in here. And then everything else in this case, just student ID and the review date, right? So everything else plus transistor, which is class ID. Make a new table. So the new table will look like student ID and then review date and class ID. Make a new table. Okay. And then this procedure may not be clean, so you may need to do it again. So first one, I guess there's no problem because there's only one functional dependency between class ID and instructor, and the class ID is already key. So this one is already Boyce card normal form. But for the second one, can you see any other functional dependencies? So if you just use your common sense about student and class. So one student can have many classes, one class has many students, and then each student may have different review dates. So basically, you may have functional dependency like this. Student ID determines student ID and the class ID together determines that. Student and class ID determines that, but the student class ID should determine that. So the class ID and student ID should be generally be a key for this table, because there's only one column here, right? So if you have, say, something that determine only one determines that only one extra column, which is review date. So the class ID, so there's a primary key should be student ID and the class ID, okay? And then you have functional dependency that is student ID, class ID together determines review date. So therefore, this functional dependency, this only functional dependency, and the left-hand side determinant is a key. So this is already a key. So therefore, this table is not violating Boyce card normal form. All right, so that is the end result. Let me see whether anybody have questions on this one. Nope. Okay. All right, so I'm going to put this aside. And then today we are going to move on to database programming. So first of all, let me show you a bunch of just basic stuff. PowerPoint. Okay. And today's not the first day we're talking about SQL. We already did SQL with DDL. So basically use database, use SQL to create tables, modify tables, drop tables, create users, modify users, and also some other database objects. But so today, for the next few weeks, we are going to just focusing on SQL. We're doing SQL programming. Okay. So first of all, okay, we already did that review. We already did that. So let me just move on. So what is programming? Okay, so just basically, some of you already taken currently taking 315, so you should know what programming is all about. But for others, database, if you take database, you probably have not exposed any programming aspect yet. So just give a simple introduction to database programming, the concept. So first of all, you understand that a computer, the brain of a computer is like the CPU, the called central processing unit, is like a brain is really the central, is really the main components of any computer. So a computer is basically just made of many dummy device, many or consist of many, that not just few, thousands, millions, sometimes billions of those micro switches. You know the switch, right? Switch can turn on or turn off, right? So CPU is just made of those large number of those switches. So each switch can be turned on, turned off. So then basically they can be used to make many different kind of patterns, very, very different, many different kind of patterns. So those patterns actually represent so-called binary numbers. Okay, so for example, if you use on to represent 1 and off to represent 0, so then you have this, if you have only three switches, then you can represent a pattern like a 0, 0, 0, that means all of them are off, and 0, 1, 0, that be, the first one is off, second one is on, third one is off. So you can represent, use those switches to represent many of those binary numbers, okay? Now, by making the CPU to turn on or turn off the switches in the logical manner, we can actually program the computer to transfer data. Transfer, for example, if you have one set of binary numbers, we can change to a different set of binary numbers by turning those switches on or off. Okay, so essentially, you can just imagine the programming is just somebody, up there to turn on, turn off switches. Of course, that would be very slow, right? So of course, we have to ask a computer to do it yourself, controlled by CPU, and controlled by your commands, okay? Now, a program, so what is a program? A program just consists of a logical sequence instructions to the computer. So those instructions just basically tell the CPU, say you need to turn on this switch, turn off that switch, so on and so forth, right? So that is how a program is giving instructions to a computer, okay? Now, since the computer can only understand the zeros and ones, you understand that? Computers are just made of, is a very dummy device, can only understand the zeros and ones. So if you say 0, then you turn off. If it's 1, then you turn on, okay? So if you give instructions like that. And then, of course, our human beings are not good in those binary numbers. So what are we good at? We are good at giving instructions or giving commands like English or English-like commands, right? So there's a gap. This gap is between humans and machines is huge, actually. So it's between binary numbers and our own language, natural language, okay? So when we write programs, so of course, because of that, the computer scientists have invented something called programming language. Okay, it's actually artificial language. It's not our English, and it's not the zeros and ones either, but it's very close to our human English language. Okay, so that's called a programming language. That is close to our natural language, but the language is much stricter and much more precise than our natural language. Our natural language has ambiguity, right? Sometimes has a fuzziness, so maybe the meaning is not very clear. So programming languages tend to be very precise and very strict, very concise. Okay. And then along the way, the computer science, when you invented new programming language, then you have to design a compiler. The compiler is basically just convert, just like a converter, convert your English-like commands in that programming language into zeros and ones. Okay, so and the result, so we are writing code using that programming language, and then we are going to use a compiler to compile that into binary zeros and ones. And that binary 0 1s, the code consists of binary 0 1s, that will be so-called executable code. Okay, so that is what a compiler is actually doing. All right, so this is basically just you can say this is you know so you get a good idea what programming is all about. So we are using a programming language to write the commands, and then we are using compiler, and then the compiler will convert your code, your commands into executable code. Okay, right. So the process, first of all, you program language, right? You write a so-called source code, and then second, the compiler will take the source code, translate that into executable code, and then when you give to end users, you will give executable code to end users. You're not going to give your source code. Source code represent your copyright. You have your copyright, and so your intellectual property. So you will not give your source code. You only pass executable code to the user. Okay, and the user will run those executable code, which will run the commands you wrote in the source code. Okay, so a compiler is a machine. So you can think of a compiler is like a machine translator. Okay, translate your source code, your English-like commands into zeros ones. Okay. And then there's something about the compiler, okay, we should understand that the compiler does not allow ambiguity and fuzziness. So if you write your commands must be very precise, must be, there's no different interpretations. So if the commands can have different interpretations, the compiler will complain. Say, I don't understand what you mean. So we'll throw some kind of so-called error message to you, and then you're going to fix it. Okay. So this process called the debugging, and debugging is, don't think errors are bad. Okay. So debugging actually for beginners, the debugging process is how we learn how to write code. Okay. So that's why I said for next few weeks, you really need to put your hands on and then try to write a code and then execute it. And then you're going to get errors, and then you're going to fix those errors. And then this kind of repetitive process will help you to internalize the knowledge. Okay. I think what time? We still have time, right? Still have like 40 minutes. Okay. And the instruction you give in the programming language must follow grammatical rules. That rules are called syntax rules. Okay. So basically, when we speak English, we have to follow the syntax rules, right? So for example, I love you. I have to have a subject, and then a verb, and then an object. So you have to follow that kind of a rule. So that's English, right? So in programming language, you also have to follow the rules. If you do not follow the rules, then your translator, your compiler will not be able to understand. Okay, so that's what you need to know about the compiling process. And so let me get rid of that. So normally when you encounter, when you write a code, execute that, and you're going to get a bunch of errors, or warnings, complaints, all this issued by compiler. It's not by computer. Okay, computer cannot understand anything. Computer does not understand any of your comments. Only after the compiler converted into zeros ones, then computer can understand. So when you get errors, those errors actually coming from the compiler. Okay, get warnings. The warning is coming from the compiler. Okay. Now, there's something similar to compiler, which is called interpreter. An interpreter is just play same role as a compiler. It translates the source code into machine understandable instructions. However, there's a difference. The difference is interpreter will just do the translation online. So whenever you run your source code, and then this the interpreter tend to run convert all your statements line by line, and then it will not save the compilation result as executable. So in other words, your source code will be executed on the fly by the interpreter. So if you have the first command, for example, I want to get this piece of data, then the interpreter will interpret that and interpret that task, and then ask a DBMS, for example, database management systems, to get that piece of data. Okay, and then if a second command is something else and does the same thing, but the whole thing will not be the whole code will not be translated into like a whole executable to be saved for future executing. Okay, so the source code actually will be, so you're going to have a source code, and the source code will be interpreted on the fly and will be at the same time executed. Okay, so that's the difference. So so that's what I'm talking about. So for example, there's a we all know web browser, right? Web browser. We use a web browser to search for information, to present the information, and the information behind is all written in HTML. Okay, so HTML is kind of it's like a programming language too. It's a hypertext markup language, or sometimes JavaScript. Okay, and then the web browser in that case will interpret those commands in HTML or JavaScript. And then, so for example, if you want that piece of text to be in bold, and then there's a web browser interpret that, and then just show that text as a bold, okay? Or if you mouse over something, you want something to be changed, and that is done also by the browser. Browser will basically interpret your code and do what the code is supposed to do on the fly, okay? SQL is also this kind of thing. SQL is just like HTML. So basically, when you write SQL commands, the code is not compiled into executable. Instead, will be interpreted on the fly by DBMS. So DBMS actually play the role of interpretation. Okay, and there's a slight difference. So in Oracle, for example, so when you write the commands will interpret it, and sometimes they save. Sometimes they save the interpretation result in the cache, not formally in the hard drive, but in the cache. So in case in the future, if the same command will be executed, and then they're not going to redo the interpretation, recompiling, and then just use whatever saved in the cache to run it, to execute it. Okay, so you can just imagine that is something like in the middle between interpretation and compiling. So compiling, you compile it, and then you save that result as executable. Interpretation, just interpret on the fly. But here, Oracle is sometimes doing something in the middle, trying to save that interpretation result. Interpretation, say for example, run the first run SQL statement, and you will have a plan to run it, and then the result, the whole thing interpretation result will be saved in a cache, just inside like a random access memory. So next time when that same kind of SQL statement is executed again, it's not going to redo the interpretation. So that's what a little bit different from other interpretations. Okay, now let's come to SQL focused. Okay, so SQL was initially developed in IBM by these two people. Do any one of their names remind you the familiar name? So we learned the boys card normal form, right? The same boys, okay, was the person who developed the first SQL, developed the programming language, okay? So, and then these people learned the relational data model. The relational data model was proposed by Edgar Card, who is a mathematician trained in Cambridge and also worked in IBM. So he was the person proposed relational model, and then the Boyce Cobb normal form. So that's Boyce, the same Boyce here. Okay. So Boyce and Chamberlain developed SQL. That was in 1970s, and then the SQL was standardized. I think it's much later, which like 1986. The first version was standardized by ANSI and ISO. There's two standard organizations. Okay. The most recent standard is 2016. Okay, and 1999, I think, was significant standardization. So basically what we're learning today, we're using today is coming from 1999 standard. Okay, now a little bit knowledge about DBM, about SQL. So basically all relational database management systems will support SQL standard. Okay, so we have Access Microsoft SQL Server, Sybase Server, IBM DB2. So many different, there are many relational database management systems. And all of them will support SQL standard to certain degrees. But does that mean they will support to the full standard? Okay. SQL implemented by Oracle support basically a whole 100% standard. So that's why we use Oracle to practice SQL. Okay, but if you use Microsoft Access or some other database systems, the SQL maybe is not supported to the full 100%. Okay, so for example, Access only support entry level of standard. Okay. Besides SQL standard, each relational database solved well, we also have additional dialect or extensions. So those are not part of SQL standard. Okay, for example, for Oracle, besides they supporting 100% standard, they also add something called a PLSQL. That stands for Procedural Language Extension of SQL. So that is just like you can put SQL inside the PSQL inside PSQL code, and about the PSQL is more like so it's just like any other programming language like Java, C#. You can use variables, you can use loops, you can use if-else. Okay, so those extensions are added to SQL. Okay, so a couple of years back, people were anticipating that PLSQL will be standardized as just standard part of SQL, but that has not been done yet. The reason for that is, say Microsoft has a different extension. It's called a Transact SQL, which is not identical to, not the same to PSQL. But in my personal opinion, I found that the PSQL is probably better. So anyway, so that has not been standardized yet, but let's just let you know that the different database systems may support the different extensions beyond the standard SQL. All right. Now, we talk about that SQL primarily consists of two parts. One is data definition language, and then second is data manipulation language. Okay, so we explain the differences. But in fact, there are a few more, some minor ones. Okay, for example, you can also have transaction control statements and the session control statements, system control statements. You can also embed SQL statements. So SQL can be kind of, if you do more refined classification, then there will be, you can have a few more categories beyond DML and DDL. Okay, so a little bit. So here, this is what we just we talked about before. DDL statements is to define, maintain, and drop objects, database objects like tables, users, sequences, database table spaces, indexes, okay, database links, all those objects. So you use DDL to do to create, to maintain, and drop, to delete. And the data manipulation language is primarily just manipulating data, database data. Okay, so those data are stored in tables, and now basically you're using DML statements to manipulate data inside tables. Okay, and then transaction control statements basically manage changes made. Manage transactions. So basically, we have to think about a transaction. Transaction is not just one statement. Sometimes one transaction consists of several different statements. So you have to consider each transaction is like a whole unit. It's like an atomic unit. Okay. So if you have several statements, and what happens if some statements are executed successfully and some others are not successfully executed? So in that case, you have to control. Say in that case, the transaction considered as failed because not all of them are succeeded. So you have examples like a commit, that means you save changes. So if a whole transaction is successfully finished, then you commit. Or if not all statements are executed successfully, then you just undo it, roll back. Okay. You can also set up like a save point. So I want to save to this point, and then in the future, if I roll back, I will roll back to this save point. Okay, so again, a transaction is a logical unit of work that comprises of one or more SQL statements. Okay, and Okay, so I think I explained that. So here, for example, so in the bank customer situation, that if you're trying to transfer money from one account to another account, so basically in that case, you have several different statements here. One is you say from one account, you need to reduce the balance, right? So you need reduce the balance, take the balance off, okay, because that transfer money, right? And then the money must be added to another account. Okay, so both transactions must be successful for this transaction to be claimed to be successful. Okay, if, for example, if only the first part in the account has been deducted, debited, but the second account was not credited, then this transaction should be voided, should be undue. Okay, so it should be rolled back. And then there's also session control. Basically, session, just like every time you log into database, and before you log out, that's one session. So you can have a session control statements to like say auto session or set rules or those type of things to set up the parameters for the entire session to follow. So for example, enabling or disabling rules or changing language settings, right? So for example, I log on. I made for this particular session, I want to change this all to, to like a Japanese or to some different languages. Okay, and the system control statements will allow you to change the properties of the database server instance. Okay, so for example, you can use that to change things like what is the minimum number of servers. Okay, and I want to kill certain sessions. So also one session maybe not up to good. So we monitor that, we can kill that, okay? And then you can also embed SQL statements. So basically this is what we, basically when you're writing in 427 class, we'll be learning how to embed SQL statements into C#, okay? So in that case, you're going to use embedded SQL statements, okay? You can also use embed SQL statement inside the PSQL. So in that case, for example, I want to get like some kind of SQL statements like a result. Okay, I query data and I get a result and I put the data into some kind of a cursor and cursor, which is like a memory, temporary memory to hold the result. And then we can just open it and close it and fetch result, fetch into two variable. So something like those. So those will be which will be inside so-called embedded SQL statements. Okay. Now let's come back to DML. So we narrow down from programming language to what? To SQL, and then from SQL we narrow down to DML. So DML now, let's talk about DML. DML basically primarily consists of 4 statements. Select statement, that is used to retrieve data from tables, or summarize data from tables. Don't forget that, summarize, okay? So you can use select statement to do calculations. So what most things like data mining or data analytics is actually using a select statement, okay? So you are using select statement to do calculations, to summarize data, okay? And other 3 is pretty has a singular purpose. So for example, like a insert, which basically just create a new records. Okay, so in a table you create a new record, then you will do insert. Or if you already have a record you want to get rid of, then you delete the record. Okay, and update, you basically, if you have record that have some values you need to change, then you do update. Okay, so be careful with update. Update has sometimes maybe confused with insert and delete. So for example, if you have a record, but record in some cells which have no values, you're trying to put values into those empty cells, that is update. That's not insert. Make sense? Similarly, if you have a record, and then some values you want to get rid of, you want to delete, but that's not delete. You are using update. You're basically just turning those cells empty, just like have no values, right? So that's also update. Okay, so just be sure that insert and delete just for entire rows, entire records, and update is just inside the records. You change some cell values. Okay, that could be turning off, remove those values, or add a new value to empty cells. So those are update. Okay, and among these 4 statements, select statement, you can work with multiple tables at one time. All others, insert, delete, update, you can only work one table at one time. Okay, so for example, to insert new records, you can only insert one record at a time into one table. Delete, you can delete multiple records or one record or maybe no record from one table at a time. Update, same thing, you can only update one table at a time. Okay, so select is the only case that you can have multiple tables, to get data from multiple tables in the same at one time. All right, so before we get into syntax, let's just talk about rules, SQL rules, okay? So remember, SQL is non-procedural language. You do not need to use variables. You do not need to use if-else statements. You do not need to use loops, okay? Because those procedures will be done by DBMS. So for example, when you're running SQL statement, Oracle will decide based on what you want, decide what kind of path will take. So for example, maybe use loops, use variables, but that is done by database systems, not by you. You don't have to specify the path for the code to be executed, okay? So instead, what you need to do is you need to specify what you want precisely. That's the keyword, okay? You need to specify what you want. So to specify what you want, basically you need to specify, first of all, type of action. What do you want it to do? Okay, you want to delete, or you want to insert, you want to update. So the type of action must be clear. The type of action, you specify whether the action is to retrieve, or to erase, or to modify, or add new records. So that is the first thing I just explained, right? So you need to know which type of commands you're going to do. Second, what tables the action will be acted on. So for example, you can retrieve records from which table, from where? The tables specify, okay? If you're going to insert a new record into which table, the table must be specified precisely, okay? Then you need to specify columns. So what columns the action will work on? Okay, so table has many columns, right? So you need to specify the columns precisely. So if, for example, if your action is to retrieve data, then you need to tell which columns data should be retrieved. If you're going to update, then which column data will be updated. Okay? So the column must be specified. Of course, when you do delete or insert, the column does not apply because you're going to insert the entire row, so which has all the columns, or delete entire rows, then all columns will be deleted. But in general, don't forget the columns. Next, you need to specify which rows, which records the action will be working on. Okay, so that's typically specified by so-called where clause. So where, you need to put a condition, and the condition will specify which records the action will be working on. So for example, I want to retrieve those rows, or I want to delete those rows, or want to insert a particular rows, or want to update certain rows. So those records must be specified. So those are the 4 things you need to specify in each SQL statement. You must done that precisely. Okay? All right, I think we have like a few more minutes. I'll talk about the syntax basically, and then actually today I don't think we have time to practice any statements. So let's just take a look at SQL syntax, okay? So first is select statement. So to select, you basically say select, from, and where. So I put a square brackets around that. That means this part is optional. You don't have to have it, okay? But at minimum, you should have, say, select and from. From part is easy. You say, I want to retrieve data, right? Which tables you want to retrieve data? From where you want to retrieve data? You specify those columns, specify those tables. And then if you have one table, just specify the table name. And if you have 2, 3 more tables, then use comma to separate those tables. For example, EMP table, DB table, and the university table, so just use comma separate those tables, okay? And then you specify which columns of all those tables you want to get data from, which columns. And again, you also specify, you can have multiple columns or just one column or maybe all columns. So then you use comma to separate those columns too, okay? And finally, where clause. The where clause specify which records you want to get data. Okay, so the table have many rows, right? So which rows you want to get? That's what the where clause is going to specify. So this condition will specify, I want to get the certain records which have employee job equal to salesman, or salary is more than 2,000, or names like have like a name like start with letter A, something like that. Okay, so all this will be specified by as conditions in the where clause. Okay, so where clause is used to filter the data according to specific conditions. After the where clause must define the filter conditions, right? And the where clause is optional. And if it's missing, then all records will be retrieved. So basically, if you say this part is missing, that means you're going to get entire column data, regardless of whether the row, because there's no records, there's no conditions. So basically, there's no condition to filter certain records. So basically, in that case, all rows will be selected. And if existing, then only the records that meet the condition will be received. So let me give you an example here. So let me tell you this how Oracle is executing your select statement here. So actually using while loop. So for programming students, you're learning while loop now, right? So here basically what does it do? So when you write a select statement, you select the columns and from which table, right? So what DBMS is actually how DBMS is executing your statements like this. First, you will take one record from the table. Okay, so basically from the where clause you find one table, right? So I say from EMP table, then from employees table, then pick up one employee records. Okay, and check say whether it satisfies the conditions. Okay, if it's not satisfied, the record will be discarded. And if it's satisfied, then the value will be specified. If it's satisfied, then that particular from that particular record, you look at the select statement and then say which column data you want to be retrieved. So you put those column data into like a temporary place. And then you go to the next record and do the same thing and check it again. So you can just do you understand this while loop here? So you're going to go back to while loop and check the next record, say whether the next record is satisfying your conditions. If it does, then that will be put into the temporary cache again. And this process will continue until all the records are selected and checked. And then all the values stored in the cache will be presented as a result. So that's how select statement is processed by the DBMS. So you understand that essentially there's a while loop issued, okay? But you don't need to know how to write the while loop, because Oracle in this case, or DBMS in this case, will interpret your what you want, interpret your SQL statement, and will create the while loop for you. Okay. So here is an example. So suppose I have a table like this, a students table. The name of table is students, which have these columns: name column, with surname column, surname column, and then lesson, and the age, and the pass mark. Okay, so I'm going to write SQL statement, so select name, surname from students. So what does it do is I will use this table, get this data source from this table, so from students, and then I will get these two columns from select name and surname. Okay, so and the result is that all these two columns will be retrieved. So in this case, where I don't filter any of these records, right? So all columns entire columns will be selected. Okay, so let's talk about, let's say if you only, for example, I want to say only one column, say select name from students, and then this name column will be selected. If you want all the columns, select star from students, so then all columns will be selected. So star representing all columns, just like a abbreviation for all columns. So you do not have the list name, comma, surname, comma, put all the names together. So it's just one by one. So it's just use a star to represent all columns. All right. Now, what if you use a where clause? So for example, if I want to find students who has age more than 20, who have age more than 20, so I'll look at age 20 column, age column. Okay. So the first one is more than 20. Second one is not. other one is not. And this one is, right? This is last two. So basically, you are telling Oracle that I want to get the last two rows, and also the first row. So any row that has age more than 20. So to do that, I select. So suppose I want to get all columns. So select star from students, and where age is greater than or equal to 20, or greater or equal to. So basically 20 should be also selected. Okay, so this is more complete syntax, more complete example, showing that you also filter records. All right, and let me just stop here. Delete statement, insert, we'll just finish a couple of views, couple of that, and then next class we'll do examples, do actually hands-on practice, okay? And also starting from this week, I said you can submit your attendance proof to e-course. I think you should be ready. So make sure that you all put your hands on, you all take notes, and then up at the end of class, put those notes into e-course. So I will occasionally check from time to time, say whether everybody is on track. Everybody is doing what they are supposed to do. Okay. Now let me say, I have 2 more minutes, say whether anybody have questions. Anybody has questions?
So do you want us to submit these notes and the ones on Wednesday together for attendance, or just for each day?
I think the way it's set up is for each meeting, there will be a folder created. So I guess you can just submit today's note to today's folder, and then Wednesday's note to Wednesday's folder.
Okay, thank you.
Okay, yeah. All right, let me stop the recording to see whether anybody else has more questions.